To use software on HPC cluster system, we use this environment modules. So let's say if you want to use some software, especially some free and open source software, so how to install this? Maybe you are very capable, and then you could do the compilation, do everything by yourself, and then to add the environmental variables and so on, to finish everything by yourself. But there are potential, let's say, disadvantages. The first disadvantage is duplicated work for some common software, for some atomistic simulation, almost all the users use, for example, CP2K. So if every user compile their own CP2K and then install, on the cluster system, you will see, I don't know, 500 installation of CP2K. This does not make sense, right? Because we only need one installation. That's almost enough. And then the second problem is unoptimized compilation. I would like to say most of the users are not really computer scientists, maybe from other domains, from chemistry or physics and so on. So maybe the compilation is not optimized. And last but not least, there may be some dependencies or even multiple dependencies. This Python package depends on that Python package and so on. This is very, very nasty to handle. This is very difficult. So the solution, a much better solution, is to ask us to install those softwares system-wide, and then to make different versions to make it optimized for the cluster. And then for you, it's very easy. Just use this as the so-called environment modules by changing the environment variables dynamically, and then to load and use the software. This is a much better scenario for you as a user, right? So how to do that? At PC2, we use the environment modules by L mode, so that we install those softwares on our system, and then you can use L module to look at the details about the installed software. For example, as you can see here, if you want to learn the details, in very details about the installation of Python with a specific version and which GCC was used to compile this Python, everything in all the details, you can find it out by using module show and then followed by the package. And then the shell is able to find this specific GCC Python version easily. Yeah, this is needed because for some software, it may only work with Python, I don't know, 7.10 or 7.12, but not working with older versions or not working with very, very new versions. So this is needed to have this environment modules for you. Believe it or not, maybe you do not believe me, but please trust me. There are about 1,500 software packages installed on the cluster system at PC2. Really, 1,500 software packages. To look at the availability of those packages, you just use module AV for availability, and then you will see output like this, the so-called gateway modules or basic modules. So because as you can imagine, there are 1,500 software packages. If you want to look at the availability of 1,500 software packages, you will see a very messy output, right? So a better way to organize this is to put the software which belongs to the same field or research directions into one gateway. And then you will see, for example, software belongs to chemistry or belongs to compiler, software belongs to, I don't know, FPGA development or library, etc. So that this minimizes the output of the list, 1,500 packages, and also make it easy for you to focus on just the modules that is useful for your research area. For example, by study, I'm a chemist. So I would like to use a module in the chemistry gateway. And then I can use module load chem. And then after loading the chemistry gateway, as you can see, the list is much cleaner, right? If you use then module AV, you will see only the chemistry-related software packages. And then among those packages, if you would like to use, for example, Orca, which is a very popular software for quantum chemistry, you can use module load Orca. If you want to look at which modules are loaded, you can use module list. If you finish your calculation, you may want to unload Orca, right? You can use module unload. If you want to unload all the modules, you can use this module purge to, let's say, to eliminate, to unload all the loaded modules in your job. And if you want to have more information, of course, you can use module help, followed by the module name. As you can see, the usage of the module system is extremely intuitive, right? Just load, unload. If you have further questions, just module help. And nevertheless, it is not easy, to find a specific package among those 1,500 packages. That is why on Noctua 2 and Otus, we provide this found and score module command, so that you can use this command, found and score module, and then followed by the software name to find out where is this software. And the name of the software given here is case insensitive and can even be incomplete, which means you only need to give some rough name for the software, for example, capital C, small p 2k, and then the relative package will be listed. So this is very, very convenient for you to use. And in the last session, we talked about Slurm JavaScript, right? And currently, we move to the part about modules. So what is our recommended workflow for this whole procedure? Here, our recommendation for you is when you write or prepare a Slurm JavaScript, first, you reset the environment modules to default by using module reset, so that you will have a clean environment. Everything is a default. And then you load the needed modules by using, for example, module load chemistry, module load G16, Gaussian 16, and then you just run your Gaussian calculation. The benefit of this workflow is this guarantees the well-defined behavior for your JavaScript. In the beginning, everything is clean in the default state, and then only load the needed modules. And this can avoid any conflict, right? So this is the way that we would like to recommend you to use in your Slurm JavaScript. And another topic is Singularity container. And singularity container is, as the name implies, is just an encapsulation of the software environment in a single file, let's say. So for example, you would like to run some calculation with software, I don't know, ABC, and then you can put the entire, software environment for ABC in one single file, and then run this software ABC on any platform. For example, laptop, workstation, or HPC cluster at PC2, or even share this single image file with your colleague. It's very convenient to use because only one file, it just works. This is very convenient for our users. And but the topic is beyond the scope of this course. And if you found it interesting, we have PC2 documentation for it. You can just simply click this link. You will have detailed information how to use Singularity container on the PC2 cluster system. Okay, so more about software. We have documentation. So if you have any questions or something that is unclear, please take a look. And also, if you have, let's say, specific questions about your application, feel free to send us mail so that we can look at the problem together. Yeah. And okay,